Hi guys, we're back with another video tutorial on the procedural effect that we are doing for Unity, and today we're gonna be generating a bunch of these balls that are gonna fall down like in the video that we have as a reference. So in our reference video we see how these balls fall down in kind of like a cascade. So we can imagine that they are being generated up, like there's a fixed amount of balls that when they go down, they go up again. They have random sizes which can vary massively. Like from, say, if this is around 100%, this is going to be like a 50%. This is like over 150%, 170% or something like that. So yeah, they are generating different sizes, and they are and they fall down at a constant speed. That is the only thing that is constant. When they go down, they go back up, and so on. So let's do that. So the first thing we're gonna do is create a prefab with a fan sphere that we are gonna be using. Great, we've got one. And we're gonna get rid of it. Good. Now we're gonna create a new object. This is gonna be a sphere cascade generator, for instance, which we're gonna put the center of coordinates, for instance, or we could yeah, we can put it there, and we are gonna create a new component that is gonna be exactly that. Create C# script, and it's gonna be a sphere cascade generator, or manager. Let's call it sphere cascade manager. Let's call it manager. I think it's going to be more of a manager because it's not only generating the and this is going to be called manager 2. And now I have to change the name of the script here in the code. This manager creates all the fan balls in necessary for the effect and moves them around, ensuring that those that leave the screen go back up. So we're gonna need a public float height to disappear, and it's gonna be for instance minus 30. I don't know. Public float height initial height, which we're gonna set to 32, for instance. So we had this cascade manager here. Oh, and we need definitely the fun public game object sphere prefab, and we're gonna assign the fun sphere prefab. Okay. So how are we gonna do this? We are going to generate bunch of spheres within a say a cylinder that has this initial and end point in the y direction and radius, and a generation radius of say 50. Don't know. the minimum scale is gonna be 0.25 on public. Max scale is gonna be 1.0. I don't know, 1.3, 0.3 on max and 1.0. So it's gonna be never below 30% of the original one and never bigger than the normal one. I don't know. Maybe that's not good enough. Maybe we want to have, I don't know, 5.7. I don't know. We will see. This is something that is gonna be configurable by the user, so we will decide it later. And now let's so in the start we have to generate the balls. So basically and we know that the public float default sphere radius is going to be 10. We're not going to be considering, we can change it later to be 11 so the wires don't touch, but we'll just use 10. So public void generate spheres. Okay, this is this generates the initial spheres. For the effect. So we're gonna be generating them. Oh, and we need the constant speed. Speed is gonna be minus, I don't know, minus 1.0, 2.0, or something like that. In the update, we are gonna be having all the spheres. We are gonna simply for each and sphere controller as in spheres float it is time delta time vector 3 movement is gonna be times delta time 0.0 f, and probably here we just want as the transform position plus equal movement. That's gonna be it. Yeah, but we want to also check if it's move the sphere, check if we have to reset it. Yeah, which we'll do later. Actually, do something like this. And yeah. So yeah, we are going to be using the position here and when we check if we have to reset. So if posted y is equal to min height to sphere, then set the sphere to the top. Okay. So that is going to be something like this: private void reset sphere to the top and fun sphere moves the sphere to a valid position at the top and resets itself. So yeah. Okay. So let's generate the spheres. So basically the way I'm going to be thinking about it is I'm going to be adding new spheres, and I'm going to try to make it make them fill the space of this cylinder. So we're going to be having the list of spheres, and we're going to be using the last, well, all these spheres to find a position up over them that is valid and still where there's still room for the new sphere. So, and actually it's going to be something like private. Actually, this is going to be private too, by the way. Vector 3, find valid pose for a sphere, and we give the radius a valid position over all the existing spheres for a sphere of the given radius. So yeah, we will see about that. Let's go generate spheres. Yeah. So how do we find a valid position? 3 pause. We're gonna find a so since we're gonna have a radius where it's valid, this radius is gonna be so we want to keep it inside that radius. We're gonna find a random position with where the ball fits inside the cylinder of the given radius. So max radius random, max random radius is going to be generation radius minus radius going to ensure this is a maximum 0, then float yeah, radius is going to be random range 0 max random radius. Okay, we could actually force the balls to go more to the more outwards, like generating like float, and val is going to be random value, and then here doing something like float t is going to be 2.0f times rand val, sorry, rand val times 2.0f minus rand val. This is actually this is going to be if you, this is a quadratic easing function that is basically making it, if we go and plot this function x times 2 minus x, we see that this is a quadratic function that has this form which makes it less likely to get a low number. It's, so for an x, you have to have a very low x to get a low y, and that's what we want. So we tend towards the outwards, which is cool, and then we will try to move it inwards or outwards depending on where we are. So a random initial position a random range minus math pi, and then we calculate a random position. vector 3 pose is going to be vector 3 sine of right angle times the general radius, height to the sphere, and math f comes around. Actually, calculate the minimum height for this sphere. The minimum height for this sphere will be the height of the last sphere or the minimum one. Float y is going to be height to the sphere if a sphere's is not null and a sphere's length is bigger than 1. And we should probably use a list instead of a. Should probably use a list. And this is going to make things easier. So list instead of count equal 1, then we don't have to check if it's null because we created in the start. So y is going to be a spheres dot a spheres count minus 1 transform position y. Now let's try to find a. So okay, let's do this. Fun sphere controller. Last sphere is null, and last sphere is this one. Last sphere. So basically, we're going to be using only the last sphere to calculate the position of the new one. So the first thing we're going to do is we're going to be moving this sphere upwards so that it doesn't collide with the last sphere. If last sphere is not null, then let's check if okay. So private board or position vector 3. Adapt position to sphere. Okay. So float vector 3 pos float radius and fun sphere other. So basically we're gonna be adapts the given position that represents a sphere with the given radius so that it is either touching or outs or further away from the given sphere other. Okay, so basically we need the vector 3 other pos. So it's going to be other transform position and float other radius is going to be other transform local scale times dot x, for instance, times radius, default radius. Right, there you go. So what we're gonna be doing is we're gonna be first check first if they intersect. This is gonna be a pos minus other, so there, pos minus other pos. This is gonna be this SQ over there, SQR magnitude. If this SQ plot sum radius radii, it's gonna be radius plus other radius, float sum radii squared is sum radii times sum radii. SQ is lower than sum radii squared, then we have to move this upwards. So first we're gonna check if we can move it outwards without it going out of the cylinder. So we are going to move it so we're gonna be doing, okay, so this is math f sqrt, this is sq float, this to move is gonna be sum radii minus dist. Vector 3 their norm is gonna be their normalized. Check if moving outwards works. Vector 3 p equals pos plus their norm times this to move. If p dot magnitude plus, no, sorry, we're only interested in the x on c distance, so float dist xc is math f sqrt p dot x plus times p dot x plus p dot c times p dot c, and then if this xc plus radius is below than generation radius, then we just move it, then that's okay, that's all right. Pos is p, else otherwise we move up. The question is how much we're gonna move up. So we need to do some Pythagoras here. We should do some Pythagoras here to really calculate this, but we are, but it's gonna be complex, and I don't care so much for a really good result. I'm more interested in something that looks okay. So instead of doing that, I'm just going to move all the distance we have to move up. So position.y plus equals this to move, and that's it. We return the position. So what we're going to be doing here is we're going to be adapting it for all of the spheres that we have. For each fan sphere controller. So pose is adapt position to sphere. But instead of doing it like that, we're gonna do it. It's gonna be easier if we do for int a equals spheres count -1 I bigger equal to 0 minus I. Fan sphere control S is gonna be spheres I, and then it's gonna be a position radius and S. And we return the position. So to generate the spheres, we just we're gonna define a maximum 100, and it's gonna be like okay. For 0 and max spheres, and last y is gonna be height to disappear, and last y is below then height top, so this initial height plus I. So we can generate a maximum of max spheres, but when we reach the initial height, then we fill the cylinder, so we stop. So we're calculate a random radius for the next sphere. Scale, max scale. Radius is going to be default to radius times scale. Find a valid position. Radius, and create the sphere in the valid position. Instantiate game object, prefab, and the pattern is going to be, for instance, transform. We're going to make him our son. OBJ transform position is going to be pos, and OBJ transform local scale is going to be a vector 3 scale. Okay. Fun sphere controller. Fun sphere is going to be a OBJ get component. Fun sphere controller. Add the new sphere to the list. Spheres. Fun sphere. So in theory, this is generating all the spheres that we need. Let's see if this works. Well, it looks like it generates quite a few. Yeah, 100, but I think it's mostly because the generation radius is very small, and we are not updating the last one. Looks like better. How about we move the camera backwards? So something like this, yeah. And we're gonna make it even bigger. Okay, so it's something like this, and 50 minus 50 and 30. Right now, the only problem is that they are going down, but they're not going up. So the only thing I have to do is reset when we go on top. I think it'd be good to generate a new scale. So basically, same thing we've done here. Find a valid position. So this is the same thing. Move the sphere there. And reset the sphere. So there's no reset function here. There's an initialization, but there's no the reset. Probably want a reset here. So basically we are going to be generating a new random rotation for all the things that we have. Random rotation. We could keep this as part of our private. So we get components in children. Random rods. And we are reset. We just do for each random rotation rod in rods rod reset. So if I didn't make a mistake, we should be yeah. So when one of these goes down, it should appear up there. Yeah, there we go. We're not finding properly the only thing is when we find a valid position for the sphere, we should probably start with the last sphere. But if let's do it with -2. No, so basically, yeah, I was using the last one, which is the one I'm usually resetting. Or no, not necessarily. Yeah, probably this would be okay with this. But instead of doing this, what I'm gonna do is spheres bigger than 1, what we do is higher y is, so no, no, let's get rid of that. And if spheres count is bigger than 0, then what we do is for each fun sphere as in spheres, y is math max, y as transform y position. Yeah, so we use the higher. So now it should be okay. This one worked well. This one worked well. Maybe if it creates a small one, yeah, well, that one is okay too. I think it's alright. Good. So seems like we have this working. I don't know, we could always try to find something like this and I'll try to find something up, I don't know. Anyway, this seems to be working, this seems to be okay. Now, so great. We are we have this working, the effect sort of working, but we need now to change the shader, and we also, I think it's going to be good if we change the background and put some particles and stuff like that. I will do that in a following video, maybe 2, and we'll be done with this effect. I hope you guys enjoyed this video. Don't forget to hit the like button if you like it, and hope to see you guys in the next video. Bye.